Alright, in this video we're going to look at taking the square root of numbers that you wouldn't normally think that you could take the square root of. For example, I doubt that very many of you know what the square root of 2,304 is right off the top of your head. But these are all perfect squares. We can take the square root of all of these. So we're going to start with 2,304. Now if you don't know what the square root of a number is, then in order to get that square root, you can do a factor tree. When we do a factor tree on 2,304, I'm going to start by dividing this number by 4. I'm going to see if 4 will go into this number. Well, 4 goes into 23 5 times, and I have 3 left over. So 4 goes into 30 7 times, which is 28. So I have 2 left over, and then 4 goes into 24 6 times. Now, we recognize that 4 is a perfect square. Some of you may recognize that 576 is a perfect square, but if you don't, we can keep going with our factor tree. Now, one thing we do notice about 576 is that the digits add up to 18. There are some divisibility rules in math, and if you can add the digits of your number and get a number that's divisible by 3, then the original number is divisible by 3. If you can add the digits and get a number that's divisible by 9, then the original number is divisible by 9. So since 5 plus 7 plus 6 equals 18, then I know that 576 is divisible by 9 because 18 is divisible by 9. So I'm going to divide 576 by 9. Now, 9 goes into 57 6 times, which is 54, and we have 3 left over, and then 9 goes into 36 4 times. Now, I can keep going if I want to, but I really don't need to because I recognize that 4 is a perfect square, 9 is a perfect square, and 64 is a perfect square. So I can rewrite the square root of 2,304 as the square root of 4 times 9 times 64. All right, well, this is the same thing as saying the square root of 4 times the square root of 9 times the square root of 64. Remember that your roots are really exponents, and the exponent rule says that if you have a product raised to that power, then every member of that product is raised to that power. So every member of this product is going to be raised to this power, and we won't worry about what that power is in this video. But that means that I can take the individual square roots here, and I just multiply what I get. So the square root of 4 is 2. The square root of 9 is 3, and the square root of 64 is 8. 2 times 3 is 6, 6 times 8 is 48. So the square root of 2,304 is 48. All right, well, let's look at a number that's written as a fraction. All right? Just as I can take a product and divide it up, and every number in the product is being raised to that power, or I'm taking the square root of every number in that product, I can do the same thing with a fraction. I can change the way this is written to the square root of 25 over the square root of 16. Well, I know those square roots. The square root of 25 is 5, and the square root of 16 is 4. So the square root of 25 over 16 is 5 over 4. Now I can do the same thing on this fraction, but I can also do something else. This fraction can be reduced. You see, 4 plus 4 plus 1 is 9. And of course 9 goes into 9. So that means 144 is divisible by 9. Well, how many times does 9 go into 144? Well, 9 goes into 14 one time with 5 left over, and 9 goes into 54 6 times. So really, the square root of 144 over 9 is the same thing as the square root of 16. I just reduced it. All right? That's what I did. So I really have the square root of 16, and the square root of 16 is 4. Now, I could have gotten this by doing what I did over here, and I could have said the square root of 144 divided by the square root of 9. And of course, the square root of 144 is 12. The square root of 9 is 3, and 12 divided by 3 is 4. Either way you do it, you come up with the same answer. But sometimes we have a fraction that we can take the square root of, but it's not in a form that looks like we can take the square root of. And this one is a good example. I am going to have to reduce that in order to take the square root. because I can't take the square root of 12 and I can't take the square root of 75. So I recognize that 12 is divisible by 3, and since 7 plus 5 equals 12, 75 is divisible by 3. So I'm going to reduce both of those by 3. 3 goes into 12 4 times, and 3 goes into 75. You know, 75 is like 75 cents. Well, we can make 75 cents with 3/4. So 3 goes into 75 25 times. So really, this fraction can be written as the square root of 4 over 25. And those are both perfect squares that I recognize. So we can take the square root of 4 and divide it by the square root of 25, and I get 2 over 5. Now the last one really looks terribly unfriendly, but we've got some options here. We can write this number as a fraction and work it like we've worked some of these. Let's do that. Okay, so this could really be written as 16 over, now we've got the tenths place, the hundredths place, the thousandths place, the 10,000ths place. So it's 16 10,000ths is what the number is. So I can write the number like this, and I recognize that I can take the square root of 16. I can also take the square root of this number because there are an even number of zeros. An even number of zeros means that it is a perfect square. So the square root of 16 over the square root of 10,000. Now, the square root of 16 is 4. 10,000 is really 100 times 100. You see 4 zeros, 2 zeros here, 2 zeros here. Well, I know the square root of 100, and that's 10. So this is really going to be 4 over 10. Well, let's write it this way. The square root of 100 times the square root of 100. So this is going to be 4 over 10 times 10, or 4 hundredths. Now, if I'm going to write it as a fraction, I need to say that it's really 1 over 25. So I can say that my answer is 1 over 25, or I could write 4 hundredths as a decimal and say that it's 0.04. Whichever one, you know, it doesn't matter. All right, but another way you can do a decimal, especially like this, is you can write it in scientific notation. So, well, not exactly scientific notation, but using powers of 10. So I could write it as the square root of 16 times 10 to the negative 4. If you understand that a square root is really an exponent of 1/2, then you can work the problem this way, and that is perfectly fine. But you do have to understand that a square root is an exponent of 1/2 in order to work the problem in this form. All right? Now, I could have, over here, I could have reduced the 16 and the 10,000, and I could have gotten the right answer doing that, but that would have been a lot of unnecessary work. It would have really made the problem more complicated. It was so much easier not to reduce in this situation. So keep that in mind when you're simplifying your square root. Sometimes you have to reduce, sometimes it's merely an option, but sometimes it's not the best option, and you just learn that with experience. Now, I'm just going to address this one briefly. This is going to be the square root of 16 times the square root of 10 to the negative 4. Now, one thing I can do right here is I can say, well, this is 4, and then if you've not worked with roots as fractional exponents, then you could say, well, this is the square root of 1 over 10 to the 4. And then that becomes 4 times, and then the square root of 1 over the square root of 10 to the 4. Now, don't forget that you know the square root of 1. It's 1. All right? So this becomes 4 times 1 over, and then that, of course, is going to be 10 squared. So really this is 4 over 100, and we're back down to this answer that we got right here.